Welcome everybody to our 5-axis post-processing course. We're about 1/3 of the way through the course at this point, and we've gone through and configured a 5-axis generic post to output code for a machine that's a Gantry style machine, what would be known as a head style machine. We've also done a quickie configuration for a table during one of our office hours sessions. So that was for Mike, and we'll be continuing with that this weekend. Office hours is really open time for you guys to ask questions about the 5-axis post. So if there's any type of output that you're looking to implement or see, now we're not going to have time in this course for everything, right? So doing some of the more advanced stuff like tool center point control output, we could spend a whole class on that. Same thing kind of with the dynamic work offset. The thing that we are slated to cover is tilted work planes. So I'll show you how to do the configuration and set up the code to calculate the G68.2 output. Today we are going to start configuring a table style machine. So I've already copied both the mcam-control file and the mcam mmd in 2017 inside shared mcam 2017 CNC machines. Now, I haven't gone through and configured those yet. That's kind of the next step. The first step is always take one of the generic machine definitions for the 5-axis and the generic machine definition that matches that machine. Now, when you're working with the 5-axis machines, when you load the machine, you go look in shared mcam 2017 mil posts, and that's where you're going to find your post processor. So we've been working on our Cincinnati 5-axis gantry, and now we've got the OKK VCX 5-ax table. That's what I've named it. So that's kind of the naming convention here. Like to put 5X in the name so we know it's a 5-axis post, and TT table, HT head table, and HH would be head. And using that convention really helps you keep things organized. Typically, when I teach people how to set up post processors, we set up the post, in this case it's the PST and the PSB file, the PSB being the encrypted portion of the post. And then I like to set it up with everything having a name that matches. That way we've got a machine definition that matches the control, that matches the post, and as long as you make sure to set the control definition defaults, you shouldn't have any issues when you upgrade to a new version of Mastercam. Setting this up inside Mastercam, the first thing I'm going to do, machine type design. So I'll go to the machine menu and select design, and then I'll do file new. And I do machine type design so that Mastercam loads with no machine in the operations manager. If you've got an existing machine loaded in your file and you go and just select file new, you're going to get the default machine type reloaded in your Mastercam file. But if you choose machine type design, that puts you in design mode, and then you load with an empty machine database. So now I'll select, actually I'll do the control definition first. So I'm going to open up the control definition manager. Grab our OKK control file. And the only thing I've changed at this point is the name. So originally this was the Haas VFTR, and I just picked it because it's kind of a similar configuration. In this case, we'll name it. Let's see what this guy's got here. It's Fanuc 31i B5. Okay, and right now you can see that we've got control type mill selected, and I'm set to default settings for control type. So right now, if I go through each of these control topics and I make changes, I'm making changes to the defaults for mill. Mastercam or CNC software originally envisioned a case where you might have somebody who's doing somebody who is your post editor who is maintaining a lot of different files across a large organization. So we're talking places like Boeing, where they've got, you know, hundreds or thousands of machines. You might have somebody who wanted to go and set up a control definition for maybe the Fanuc 31i, and yet they've got a 31i on a router, and they've got it on a lathe, and they've got it on a mill turn, and they've got it on mills or wires or whatever. And the idea being, you could have one file that had a ton of different settings for all of these machines. In practice, almost nobody does this. And the reason is that unless you really know how things work in the background, it's a good way to get the wrong set of settings at the wrong time. The common complaint is that people go and they upgrade Mastercam and their settings for their post change. And the reason is because they didn't set the control definition defaults from the very beginning. So what we're going to do is we're going to reconfigure this. I'm going to leave it set to mill. I'm going to go into the post processor list. And right now we have default settings for the mill. This is for the control type. And we have a set of settings that are linked to this post processor. Generic Haas, VFTR, 5X mill. We don't know if this set of settings and that set of settings are actually equal right now. And really, we don't care, because we're going to go through and we're going to set up a new control definition. The important thing is that if we do it in the right order, we only have to set our settings once. So what I'll do here is I'll click the definition for the generic Haas, and I'll select delete files. And then I'll click OK. And then I'm going to save it. So basically, we've just cleared out all of the posts that were linked in this mcam-control file. Now I'm going to go through and I'm going to set my defaults for the Fanuc 31IB, 31IB5, and then we'll go and we'll link our post. And by doing it in this order, we're going to get it set so that all of the settings will always be the same no matter where the post is located. Okay, I'm going to leave it .nc for the moment. Scott, I'm basically modeling up the machine that you mentioned on that thread on LinkedIn. So is there a specific NC file extension that you guys use for the files that you load on this machine? The default right now is NC, and if you want a different extension, just let me know. So we can come back to that one. So we have some options for comments that we can actually control and suppress the output at the control definition level. So you'll notice output operation comments to NC, that's turned on by default. Let me go and move this little chat box over there. So we can also choose to output the machine name, we can output the group name, we can output the group comments. But these don't come out by default unless you turn them on. Maximum characters in NC comment, I'm going to bump up to at least 120 characters and probably more like 256. Now, the reason I'm bumping the maximum characters in the NC comment block up, if you've ever wanted to enter multi-line comments in the comment box, is there any way to allow more than 256? Practically no, because I think the Mastercam system itself, because I when I was at CNC Software, we tested this, and I believe 256 is the limit. You can test it. They may have changed it for Windows 10 going on, you know, in 2018. I don't know. You'd have to ask CNC, really. You know, you can test it, and the way to test it, I guess, set it, there we go. You try to set it to a higher value, you can see right there, yeah, 256, 0 to 256 is the limit. So I guess the secret then is you're going to have to enter multi-line comments and digest them that way. What are you doing it for, a Siemens? Mazak. Gotcha. Yeah, unfortunately, that's the input limit that Mastercam limits you to feeding into the post. In the post, the limit is like 300 and something, because MP has a specific number of columns, and after that it stops reading. And it's like, we hit the limit one time. It was like 380 or 370, something like that. I tell people not to go above 200 characters in a single line, because you can do multi-line statements. You do what's called line continuation. So if you have a really long test that you're doing, you know, you want to test this condition or this or this or this or this, you can break at the condition. Okay. Start with 2 and we'll go by 2. Yeah, I can't remember what we had to do for multi-line. Might have to put in like a special character and then use that to break the output. Alright, let's get this set. Stage tools. All the linear stuff should be default arc. Make sure that we do helix in the XY plane. And we probably want 360. We'll do 360 in XY, but we'll have it break in quadrants if we're in YZ or XZ. Alright, so this is all the kind of default settings for this control. We've gone through and we've set what we want all of our defaults to be. If I go and I look at arc, you can see that we're supporting arcs in all the planes. The output is going to be IJK, so delta start to center. For arc breaks, we're actually allowing 360 degree arcs in XY, and we're telling it not to break arcs. And what this will allow us to do is turn on comp and then do a full circle and turn off comp, which is kind of a nice feature, and it's actually nice too if you're doing helical motion, because each part of the circle is only going to be one piece of code instead of 2 or 4 pieces of code. Now, normally I wouldn't do this. Normally for most controls, I'll turn off allow 360 and I'll have it just break everything at the quadrants, because it just tends to process better on older controls. Newer controls, it shouldn't be an issue. So don't break arcs, allow 360. And we'll save those to the defaults. So now I'm actually going to go into the post processor list, and we're going to link in the OKK post and select OK. And now I've added the post to the control file, but it's not yet saved. So when I select it here, you'll actually see I'm going to click outside of that field, and you'll see there's this little like paper icon with a plus sign to let you know you've added a post, but the settings aren't set yet. And then we hit save, and now all the settings should match what our defaults are. Why not allow all 3 planes? It's just personal preference. Partly it helps show me when I'm in a different plane. So I know that XZ and YZ are all going to be broken at the quadrants. So when I'm just scanning the NC code and looking at the output, if I just see, IJ and a Z value, then I know that that's, it's an XY and it's doing a 360. And it's the same reason for helix support generally. You can do helix in the other planes, and sometimes it's actually a good idea if you're using like a right angle head, but that's really the only time when I'd want to do all planes supported for my helical support. Really, what other tool besides a right angle head are you going to do helical motion in the XZ or YZ plane? It's just one of those things that rarely comes up. I guess on a head. Yeah, for the table, all of the cutting really takes place in XY anyway, since we're just positioning the table and then moving the tool in to do the cut. So, do tilted planes output as if XY? Yes. Tilted work plane does that, and that's the whole point, is that it allows you to do cutter comp. It allows you to use regular planes, and it uses can cycles. So if you're on a head machine and you're on a lot of times this doesn't matter for a table. It's really head and head table style machines where you really need things like tilted work plane. I like tilted work plane, especially on those type of machines. Is it as necessary for a table? No, not really. Especially not if you have taken accurate measurements of the machine, so you know where all the offsets are. Then, as long as you set up Mastercam correctly, you're not going to have any issues. Okay, so got all that saved. Now we're going to do the machine definition. Okay, so here we've got the OKK, and we're going to rename it. VCX 500. VMC. And we're going to open up a different control definition, which is our OKK. And that should have now, sometimes you actually have to save this and then like reload it. So it looks like it maybe didn't get rid of our definition like we thought it did. You can check that. Yeah, sometimes it's just a little funky like that when you're replacing a control definition. Make sure that's set right. Now, if we look at the setup, nice thing is almost every machine tool manufacturer at least has some kind of information about the machine on their website. So this is the VCX 500, and we get a picture over here to the left. And the picture tells us 1,000 words about the machine, right? Because here we've got all our travels. So 700 millimeter X, 850 millimeter Y, 610Z. But then we get A and C. And we look at this, and you can tell right now that it's probably tilting negative. We can tell it's probably tilting negative because we look at this travel range right here. Minus 120 to plus 30. So what this machine is designed for really is to tilt this platter negative 90 degrees. So you get access to, all these different things right here. Hold on one sec, guys. So when we look at a machine like this, and we look at the picture and we look at the travel range, it wouldn't make sense for it to be negative tilting towards the back of the machine, because that would mean that the trunnion is tilting away from the operator, and with a machine with a travel like this, that's just probably not very likely. Machine tool builders are a little smarter than that these days, and so with a travel range like this, I would expect negative tilt means that the trunnion is going to move, the bottom of the trunnion is going to move towards the back of the machine, and the face of this platter is going to be facing us at negative 90 degrees. So knowing that, we can begin to make the configuration for the machine. We'll check this real quick. Spindle speed, magazine capacity, table size. Now, this doesn't matter so much for configuring the inside of the post, but it is nice information for building a template file in Mastercam that's got our basics in it. So if I was setting up a 5-axis machine like this, I would probably make a solid of the table so we at least know where that is. Now, the one thing we don't get here in the information is the offset distance from the face of this C-axis platter to the center of the A-axis rotation. So that's something we'll still have to calculate. Scott, if you know that and you can tell me, I'll just plug it right in. So now we can go ahead and start configuring this post. For the layout of the machine configuration in the Mastercam machine definition, we could actually just use this as is. Oh, you've not yet got it going. Oh, that's okay. If you have any of the machine manuals, you can look in there. And typically with the stroke diagram will give you the information of where that platter typically is. And the other thing is you can ask your applications engineers who are setting up the machine, because they have to enter that distance somewhere. So it's usually in one of the machine parameters. It's like the 19,000 series. 19680 rings a bell. There's a few of them in that range. So we could technically leave this the way it is like this, and it would operate Mastercam just fine. But it doesn't really match the actual configuration of our machine. When we go back and we look, this to me, looking at this, here's the spindle, and that obviously moves up and down in Z. It looks to me like this moves in Y. So looks like this tracks back and forth in Y. And my guess is that this moves in X, or the table moves in X. So which is it, Scott? Does the table move in X, or does the spindle move in X? Table moves in X. Okay, good. So in our configuration here, we're going to do a little surgery. So we're going to leave an X and a mill table, and on the X we're going to add a component. Actually, I prefer drag and drop, so we'll go in our little component file thing down here, and we'll go find a VMC A axis. We'll drop it on our X as a child. There's our A. And then we'll grab a C, and we'll drop it as a child on the A. And it ends in a work holding component, so it's either got to be a mill machine table, or it's got to be something like a mill rotary axis chuck. In this case, we'll just leave the table on there. So if we look at our A axis, when we select an axis of rotation in this dialog, we're choosing the actual axis that we rotate about. When we set up the vectors in the post, we're actually choosing two vectors that are perpendicular to the axis of rotation. And they tell us the zero starting point of that axis and the direction of travel. Here, we actually have a clockwise, counterclockwise travel selection button. So here we could say, okay, this is X, but the 0 degree position for our A axis is Z positive. Remember that none of these settings right now get read by the post processor. This is just to make sure. This is our C. Yeah, VMC C axis. And that way. So X, A, C table. And on the spindle side, we're going to add a Y axis. And I think Z actually rides on the Y. So we'll do it that way. We've got our Y, we've got our Z, we've got our tool spindle. In the VMC tool spindle, this actually controls the min-max RPM you can enter in the Mastercam dialog, So we do want to set it here. So I don't know if it's 12 or maybe 20. Do we have pictures that explain this last screen? This is kind of explained a little bit inside the Mastercam help file. The important thing for us to remember is that they haven't hooked it up in the new posts. They've just started to do that. So I think in 2018, I haven't downloaded the latest version of the 5-axis post, but they're just starting to hook this stuff up. Do I have anything that explains this screen? Not really. I mean, you can look here in the help file, which will give you information about the general topics in this, about this dialogue. And in the field definition, there will be an entry that relates to, let me see if I can slide it over a little bit. There will be an entry that relates to each one of these options over here. Well, I mean, this machine right here, this is the axis of rotation. So this platter rotates about Z, and the 0 point is the Y for the A. So for the A, it rotates about X, and the 0 point is vertical. That's how it rotates there. And when this platter is facing up, it's at A0. So before we can save it, we have to go set our axis combination. Make sure all those axes are selected so that Mastercam knows it's a 5-axis machine. And I'm going to load it into this little test program. So if we look at the post, yeah, so Mike says, didn't you say that these settings have no effect on the actual output of this post? That's completely correct. So they are hooking them up to the post kind of as we speak. So in the future, the settings will change as you change values inside the machine definition. That's been the promise for a long time. I've heard, oh, it's coming out next, next whenever for a long time. So it's not that I don't believe they'll get there eventually. The thing is, this post that we've been working on already in class and we've already set up for a head-head, it's been around for a long time. They've fixed a lot of bugs with the post. So to me, the logic inside it is really proven out very well. I mean, we're talking, it's been used on tens of thousands of different 5-axis machines over the years. There's something like 250,000 seats of Mastercam that are out there, not including the pirated ones, of which I wouldn't be surprised if there were 250,000 pirates out there. So you're talking a huge pool of people that have been using the technology for a while, and yeah, it's hooked. Oh, yeah, it's hooked up in MP Master now, but it's not 5X. Yeah, I haven't looked at the 2018 5-axis post because they're supposed to be hooking it up. But yeah, I think personally it is best practice to set them all to match. That means if you get a new copy of, the new Mastercam comes out and there's this new generic post and you want to use it, well, now your machine definition file already works. So you can just, plug in the new post. It's going to read your settings from the MD. Boom, you're off to the races. But we've got to focus here on configuring this post. So this is just a copy of the generic Fanuc 5X mill post, and we start at the top down. Most of the time, we don't need to mess with the MP executable process controls. We can leave the defaults here. It's really when we get down kind of here, work offsets. So force work offset, yes. Use first work offset. Do we want to limit our output to only one work offset? That's the question here. Yes or no? In my case, I'll say no. That way we can use multiple work offsets. Use gear code. Probably. We need to find out what the clamp and unclamp codes are for the C-axis and the A-axis, but we probably want to set this up to use the clamp codes. Max spindle speed. I don't know what it is for this particular spindle. We're just going to put 20 for now. Scott, if it's something different, let me know. Use feed rate. This is really going to depend on the options that are purchased for the machine and that are available for the machine. Most of the time when people first start getting into 5-axis, 90, and to tell you the truth, even most of the parts that I program that are 5-axis, 90% of the work is 3+2, because that's the kind of component that you're making. It doesn't make sense to try to do a 5-axis multi-axis cut on a part that's prismatic. Said clamps right. Is that not for M38, M39? Well, it's really going to depend on the machine tool builder. Not spindle gear. I'm talking C-axis and A-axis clamp and unclamp. Usually it's like M10, M11 for one of them, and then like, M19, M20 or whatever. That one might be, oh, I get what you're saying. Yes, this might be for spindle gear codes. You're totally right. So that's like M40, M41, that kind of thing. If your machine has, yeah, you're totally right about that. If your machine has a gearbox for the spindle, then you want to use this. Otherwise, if it's like a vector drive, we just need to set the min-max. We'll come back to the feed rate stuff. Always leave P-ang output and S-ang output set to 0 when we're setting up. And when we get down here, primary is going to be C, and our secondary is going to be A. We'll make the dummy B. Machine type is 0, so it's a table, and we can leave it set to that. This only applies when M type is 1 or 4, so whether it's 0 or 1, it doesn't matter for this configuration. We'll just set it to 0 because it doesn't matter. Primary. Our primary rotates about the Z-axis. So when our machine's at home, this table is flat. It's pointing straight up at the spindle. and that is both the C-axis home position and the A-axis home position. Now, whenever we look at a machine, and I don't care if it's a head-head, a table-table, or a head table, or even a nutating, one of the first things that we always want to do is to know how can we get just the secondary axis to rotate. So if we're on a table, we just want to be able to tilt the table, right? We want to be able to tilt A to -90 and have this platter be vertical instead of horizontal. We want it to be measurably up and down and facing towards the operator in a vertical configuration. And in order to do that, the 0 point on that is critical. So what we need to have is a situation where the 0 point of the primary axis, in other words, the vector that we're telling it, hey, this is our 0, we need to have that 0 aligned with the spindle axis when we rotate A. So here's what I mean by that. We can have this 0 point be one of 4 directions. If we're rotating about Z, what are the 4 directions? We basically got plus or minus, and with plus we don't sign the variable, vec x or vec y. So the rotary 0 can be vec x, or it can be negative vec x. It can be vec y, or it can be negative vec y. So those are the choices that we have. But what do those choices do? Okay, if we look at our 0 and we look at our picture, so when the machine def is hooked up, will it nullify this section? Basically what's going to happen is that these variables are going to be hooked up to and set by the settings in that dialog picture. So will it nullify this section? I truthfully don't know if this section will be in the post or not, but what I can tell you is it will be setting these variables. Yeah. So 0 point. When we're looking at this, if we rotate A -90, that means we want the vector 0 for our primary pointing straight up. So if we're looking down at our platter, and imagine this is our vector. There we go. So if we used vec x as our 0 point for the C-axis, when we look at this thing at the right side, I'm looking in the right view. So the right plane is what we're using to rotate A, right? Imagine if that we're looking down the center of our A-axis. And so what we're going to end up doing let's say this is our rotary center point. So what's going to happen when we rotate that machine -90 degrees in the A-axis? The whole table is going to rotate so that this platter is now facing the operator. If we look at it in isometric, That's what it's gonna look like, right? So when we make that rotation, if this is our vector, now we've rotated our A 90 degrees. Look where our vector's at now. So this isn't the 0 point, because if this were the 0 point, we'd want this vector facing up, and it's not facing up after we made the rotation. So what's going to happen when you do your output here is you're going to get C90 or C270, basically 90 or negative 90 from this rotary axis, because in order to have this tool vector facing the spindle, it's got to rotate. So let's look at it again. And instead of this being vec x, let's rotate it. Oh, let's go back to our top plane. What happens if we use negative vec y for our 0 point? We look at this from the right side, and we rotate it. So planes, right side, rotate. I'm going to rotate about that point. 90. Oh. Let's do it again. Rotate. Copy. So what I'm saying here is, all we're doing is imagining in our mind for the moment what happens when we rotate the secondary. We're talking about the vector for the primary 0. So if we go back and we look at the post, I'm talking about setting the primary 0. If my primary 0 is negative vec y, and I rotate, because the direction doesn't matter. The direction just controls the sign of the output for your rotary. Is it negative or positive? If it's reversed, you switch it. That's it. But what we're talking about here is setting the rot axis 1 0 point. So if I'm at negative vec y and I rotate my A axis 90 degrees to reposition my trunnion, so my table is now vertical, look at where negative vec y is. Is it pointing towards my spindle? No, it's pointing away. So what am I going to get on C for output? Because Mastercam's going to rotate this tool vector. So I'm going to get C180, A90, or A negative 90. So the only solution that would work on my primary 0 for use with an A-axis secondary is positive vec y. Now, this is assuming we get the A-axis rotation right, because what do we need from A? We don't need 90, we need negative 90. So let's see what we're getting. I'm actually going to leave it like this because I want you to see the difference in output. So here's negative vec y. Here's for the A. This is not right. What do we have set right now? What axis are we rotating about for the secondary with all our settings right now? Y. And I'm not saying Y as in WHY. It's the Y address. And that's correct. And we can tell it we're rotating about Y because there is no Y in the vectors that are being used. So this is still going to be Z, but positive rotation. So let's look at a vertical vector. Let's talk about this in terms of the A-axis. So again, a lot of this is really just kind of a thought experiment that we go through. Right? So if we're rotating to A, that means this is basically vertical. So we're on the right side. Okay, so now what we're talking about, why not make a chart? I like to make people do their own work. I don't just want to give you everything. You got to think. You got to think about what's going on mathematically, because, you know, tomorrow it's going to change, and the method by which we create the madness is mathematics. So start thinking about it in terms of the math that's going on behind the scenes, because the method may change. The underlying principles behind the math won't. So what are we doing here now? We're looking at positive rotation direction. When we have this table, we want negative to go to the left. And we're always talking about movement in terms of this vector. So if I'm looking at this from the right side and my vector rotates to the left, I want that to be negative. If it rotates to the right, I want that to be positive. Now granted, we can only go 30 degrees, but we can see that if this is vec z, we want positive rotation towards positive y. So if we look again at isometric, rotation this way is positive, which means vec z rotating towards positive vec y, not negative vec y. And so what we'll see here is our 0 point should be wrong. So let's see if I'm a liar. So first thing we'll do, you can see I've got, for my curve 5-axis toolpath, I'm cutting the classic circle. Okay, I just want to spin my primary axis. I want to drop down in Z, so I want to rotate A. I want to drop down, and I want to spin C to make a cut. Almost always without fail the first test I do, because if you can't make that work, how the hell are you going to make an impeller? I mean, it's a serious question. I see so many people who are like, I'm going to buy a 5-axis machine. I'm like, great. So you're going to set it up? Yeah, we're going to make this cool impeller. And I'm like, okay, I get it. You want to see the machine dance. You want to be able to make something cool and sweet and something to show off and all that stuff. Are you going to make impellers for a living? Because there's a lot of work that goes into making an impeller, and you know, if it's not going to be part of your actual business, you might consider starting with a simpler test, at least until you make sure your post is right. Okay. Let's see where we're at for time. Ooh, goody goody. We're coming right up on the time to take a break, but let's get through this. Okay, so we're doing our curved 5-axis. Change the NC file name so we don't get barked at. And let's look at our output. Aha. So in this particular post, there's a line of code here that we can use to debug our parameter output, and I forgot to put the pound sign in front of it. And so what you see here in our NC code is all of the parameter debugging. So all of this data, all of these parameter codes are available to us to grab pieces of information from inside Mastercam and tool data and all that stuff. And then you can see here is where we finally start some output. And we read a bunch more parameter codes. And eventually down here somewhere, we'll actually put out some NC code. But let's fix that and repost. Save my file. Okay. There we go. Much, much better. So what did I get? No, this makes perfect sense for C. It should be 0, but I told you we were going to get it backwards because we didn't change the Y position. So when we go back and we look at row axis 1, that should be positive. And that's why we're getting the 180 flip. Okay, positive vec Y. Save it. Make sure I save it. Repost. And now it's right. Except vector rotation and table rotation are sometimes backwards. We got everything cool except our machine cannot achieve positive 90. So what do we need to do? We need to reverse the direction for the secondary. So we reverse the direction for the secondary by changing the sign. And now we have perfect NC code output to cut that feature. Now, admittedly, this feature is a circle. It's nothing super fancy, but the math that we just did is pretty cool. Because by changing these directions and these signs around, we can take this generic post and we can configure it for 2 rotary axes located on the part. We can do it located on the head, or we can split them between the spindle and the part side. And the only thing we got to know is, now we show the tool moving this way. In reality, the table is moving that way. So as I move through here, this is what's happening on the machine, right? Now, this part isn't rotating, but the table is rotating. So all we got to know is we're moving on this circle. If we look at it in top view, we're moving clockwise. Is clockwise rotation positive? That's the question. Because that's what we're getting. That's what we're getting in our NC code. Now, counterclockwise is the standard. That doesn't mean it's true on that machine. Why? Because everything, every setting on your machine is controlled by a parameter. There is a number somewhere in the control that says this does this. This rotates like this. And if you change it from 0 to 1 or 1 to 0, it goes backwards. So, is this clockwise? Yes. Is it positive? We don't know. We don't know till we physically test it on the machine. But how do we change it? Changing it is easy. Changing it is adding or removing a minus sign. It is the easiest thing in the world. And this is why I say, yeah, it's great that they're going through and they're hooking up the machine definition to work with that visual box. You know, this is great. Okay, I get a machine definition. I can come in here and I can select something. And I can go in here to my A-axis and I can say, okay, it rotates about X, and this is my 0 position, and it's counterclockwise. And if I want clockwise instead, I can go in here and I can change the switch. Changing the switch here, let me tell you what's going to happen. Inside the post, it's going to do this. Or it's going to do this. That's what changing that switch is going to do for you. It's going to reverse the sign. So we reverse the sign. We repost. And now clockwise is negative. Now, if that's right, if we go out to the machine and that is negative motion, we've done our job. But now the next question is, okay, well, how do I get positive motion? That is controlled in your toolpath. So once you've got a path in Mastercam that matches rotational motion and positioning on the machine, then you just have to know how to control the path inside Mastercam. So now I've reversed my chain direction, and what should I get? I went from negative to positive. Okay? So we just took the generic Fanuc 5x mil post, and in about an hour, we went through and showed not just, setting the values. I can do that in 5 minutes, but really kind of hopefully helped explain what each one of these positions does and how you can tell if you're set, 90 degrees off or 180 degrees off. And if you're off, change the 0 position. If your rotation direction is reversed, change the sign of the direction. Okay, if you're off for your C 180, it's probably this sign. You've got a negative where you should have a positive, or a positive where you should have a negative. If you're off 90, it's because you've got these reversed. Or you're off 270. So 90 or minus 90 or 270 off, you've got these reversed. And 180 off, you just have to change the sign of your 0. Positive to negative, negative to positive. Does that make sense if I break it down in those terms? I hope it does. Hope it didn't just add more confusion to the mix. But tell you what, we are just a little bit over for our break time, so I'll go ahead and stop the video